Hello, good evening, friends. Welcome to yet another session of embedded system programming. And today we are going to discuss about embedded programming. Okay, this is a very interesting one. And what you have joined this program is only for this. And this is what the ultimate one. Okay, I have requested so many times for you to master C programming. It's for this only. There are only two things. There are two skills in this whole course. One is C programming on computer. Other one is C programming on electronics. That's it. That's called embedded programming. I'll explain to you. I use the word called embedded programming. I'll explain to you the difference between embedded programming and embedded system programming. There are two are different. Okay. I'll explain to you shortly about these things today. And maybe at the end of the class session today, the first and second session, you should be able to start controlling LEDs and 7 segments, everything. And that's what we wish. And anytime if you have any doubt, you can ask me. Okay. So today is a session 1, and the first session is going to be controlling LEDs. That's one of the, like when you learn C programming, you learn first printf, and you will try to display hello, welcome world, hello world. Okay, like something you will display, and you will assign a variable and print it. You want to make sure that you are able to compile and print it like that. Every system, whichever embedded system you take, the first thing should be controlling LEDs. That will give you the good idea to you about how do you start. Okay, so it's a quite interesting one. Maybe if you find it tough today, then let me know, because it's not as tough as I think. But if you find it tough, let me know. Okay, so 1 minute. I think sometime I do. Okay, so now let us start with a simple one. So we know, we see, once again I'll start about what is electronics. So in the typical electronics, we have a input, output. That's all we have been discussed so far about what is electronics. Am I right? So now we have been traditionally thinking that there are so many components which connects to the output. Am I right? But right now, the one small change here is this. What is the change? The input is separate, the output is separate. So input go to the bulb, the output is controlled by a switch. Please understand here. If you could understand this, is very good. This is what exactly you are embedded. Beauty of this is this. There is no link between input and output. Am I right? There's no link. Can you believe it? But we have discussed electronics means the relation between input and output. That's correct. If you change input, output will change. But there is no connection between them. In between, you have a computer. When I say computer, I repeatedly telling you it has 3 parts. One is CPU, ROM, and RAM. CPU for process. That's what you call microprocessor. And ROM for program. And RAM for variables. Because since you cannot write into ROM, this is a read-only memory. Whereas RAM, you can write it. That's the thing. So This guy, the computer in between, who connects the input and output. Okay. Now, let us say I'm telling this guy in English, hey, this is a bulb. And here is a switch for you. And here is a switch. I'm telling this guy, watch bulb. He can watch only the, since this is a box, he can watch only this bulb. When he is watching the bulb, yes, today is the start. Today is the start. So we are telling him, watch bulb. If bulb is on switch. Else, off. Do you understand this? That is, you will be very surprised. I know that. I know that you have been thinking something great or some big things about embedded. If you understand this, you understand embedded, please. If you don't understand, let me know why you don't understand. Then I told him, go to start. See what our man is going to do, the guy sitting here, the computer, he is going to watch the bulb. He will watch the bulb. Oh, bulb is off. The moment the input switch, the switch is off, the bulb is off. When the bulb is off, then this guy will say, bulb is on, then do this. Since bulb is off, he will off the switch. So this is output is, you connect another bulb. The bulb is off. Now, if I on the switch, then the bulb is on. I told him the bulb is on switch. So he will on the switch. The bulb is on. I can tell him other way also. See that if the bulb is on, off switch. If the bulb is off, on switch. You understand? Now, if the bulb is off, this guy see bulb is on. No, bulb is off, so he will on the switch. So this bulb will become on. That means that when you off it, this become on. When you on it, this become off. These are all very, very simple to understand. Just because of it is simple, don't think this is not important. This, what I have written in the table right now, if you, on the board, if you don't understand, let me know. This is what all about embedded. Here there's a switch. Here there's a switch. I may tomorrow connect a temperature sensor. Or I may connect water level sensor. I may connect anything to convert to voltage. No, for this guy is a black box. He cannot watch this bulb. This is, he can only control, this is only out pin. This whole thing is in the box. This guy don't have access. Because somebody has asked that both the bulbs are visible, right? No. For you, the input bulb, input switch are, you cannot control. You cannot control the switch. The input bulb and the switch can be controlled by only the computer, not by you. You can control only this switch. As a human person outside, you can control only this switch. This is only controllable. And you can watch only the bulb. And this guy, the computer, can only do this one. Otherwise, how the guy will know? If you don't have a bulb, how the computer will know that whether whether you on the switch or not? Let's say you have a switch here. This guy would watch, na? How that guy will know that? Am I right? You should know that what is the status of switch. If the bulb is off, switch is off. If the bulb is on, switch is on. Am I right? Now, this has been slightly modified. Very simple, slightly modified. Because the trick was all the CPUs inside computer CPU, they always accept only. Oh, no. You can have anything. We'll discuss about that. The CPUs accept only 8-bit. 8-bit. Please understand, not 1-bit. So, this guy can read only 8 pins at a time, not 1 pin. Same way, this guy can control 8 pins. Right now, to make the complex less, see, we have input, we have output. Temporarily, till we become understanding the whole thing, let us not worry about input. Let us not worry about input. We worry about our output. So this computer is having 3 parts. I told you repeatedly, this guy is having 3 main portions: microprocessor, ROM, and RAM. Your software is there in RAM and your variables are there in RAM. Okay. No, we don't have a C programming class today. We don't have a C programming class today. So now, you have only output. I have out means 8-bit. We'll discuss about later 16-bit, 32-bit, 64-bit. Right now, let us assume that the output minimum is 8-bit. I cannot do 1-bit. Please understand. I can do only 8-bit, not 1-bit. That means that if I output, it will control all the 8, not 1. If I say that, if I tell the computer, you out 1, you know what he will do? He will convert the 1 into 0, 0, 0, 0, 0, 0, 1. This is what he will, for him, 1. If I tell him, hey, you out 55, he will convert it to 55 into 0, 0, 32 plus 16, 48 plus 7. You'll make this. And for 1 means here it is 5 volt. 0 means 0 volt. And also here, if I say 55, it is 0, 0, 1, 1, 0, 1, 1, 1. Okay, this is bit 0, bit 1, bit 2, 3, 4, 5, 6, 7. Always understand, this is always a group of 8, not 1 bit is not possible, please. That's the way they designed it. That is the way they designed it. Okay. Here, if it is 0 means 0 volt. 1 means 5 volt. And the 7 is called MSB. And 0 is called LSB. Least significant bit, most significant bit. This is 2 power 0. This is 2 power 7. So, if you output any value, that will go from here. This is 0, 1, 2, 3, 4, 5, 6, 7. You understand? And the beauty is, this whole thing is in silicon inside. The whole thing is silicon. If you get an IC, what is coming out is this 8 pins. This 8 pin only communicate with the outside world. So we call them as this 8 pin as a port. We call them as a port. And this is called output port because we are sending it out, called output port. So understand that. So this is what an IC, a computer, and how they are communicating with the outside world. It's quite simple. Now, the trick here is I can have in a thing, let's say I have a computer. I can have n number of ports, not only one. Think of it. I can have but all of them are 8 bits, not less than that. We are assuming right now this is a 8-bit computer, so that's why all are 8. If it is a 32-bit, then it will be all 32-bit. Okay, that's fine. That we will discuss later. Right now, let us try to master the 8-bit first. You understand now? Now I can have n number. Let's say this is called port 0, port 1, port 2, port 3. And you have a computer, there's a port. How do you connect them? For them, they have given, even though we call them everything, let's say this is inside the chip. They will give you the data sheet. In that, you take any computer, man. You take any microcontroller, whether it's 8051 or ARM or PIC or Atmega, whatever it is, Atmel, whatever it is, doesn't matter. The beauty is, what is the beauty? Each one, for this guy, there's an address. Let's say this guy is having 30. This guy is having 40, 50, 60, like that. That we will see that. We will see the data sheet. How do we get these addresses? You understand? So each one is having an address. The computer, you tell him character *X. See, CHAR is 8-bit. CHAR means 8-bit. *X. Okay. So now I'm telling that I'm assigning a pointer. I say X is equal to 30. *X is equal to 1. Then what happens? He will convert the 1 into 0, 0, 0, 0, 0, 0, 0, 1. We put 30. At 30, he will put 0, 0, 0, 0, 1. 1 means 5 volt. All of them are 0 volt. You write only this program. Very simple. That's why I explained about pointers in the C session. Then, if I say add here 40, and if I say here 2, 2 means 0, 0, 1, 0. Now, here will be 0, 0, 0, 5 volt, 0 volt. If I say 50, here, if I say 60, you can ask me how much I can have. You can have 1000. You can have n number of ports. It doesn't matter. Nobody depends on the chip. Each one is occupying about 8 pins. So if I add more pins, then the chip size will become big. This will become costly. That's it. So it doesn't matter. You don't. So think of it. How many bulbs? If we have a 4, I can connect how many bulbs? 32 bulbs. So understand, we are using a 8-bit computer. Because we are using 8-bit computer or 8-bit microprocessor, both are same. I'm just using sometimes interchangeably. Why I'm using the computer word is, it is very important for you to understand you are programming a computer inside. That's it. Don't think that you are doing something great. You do here, na? See, you write a program, character X. X is equal to 1. Printf %d, comma X. Now the same program I'm telling you that CHAR *X. X is equal to 30. star x is equal to 1. That's it. Both are same. Here, you are calling the printf. You don't know what the printf is doing. It's going to monitor, but here you know exactly. That's why this is called firmware. This is called software. Understand? This is called firmware. You know exactly what you are doing, what you are controlling. So please understand the thing. That is, your system, electronic system, we are talking about only output now. Tomorrow, next class, we will discuss about input. This class, we are discussing about only output. Irrespective of any microcontroller, I don't mind what microcontroller it is. You use any microcontroller. All the microcontrollers are having the 3 units. One is a microprocessor, one is ROM, one is RAM. That is a compulsory for every microprocessor. If you use microprocessor, ROM is must. If you use microprocessor, RAM is must. Without this, nothing will work. Now, what happened? I added so many components here. These components are connected here to this computer, 8-bit. And each one is having address. Each one is having address. Here we have a small block. Okay. That guy, microprocessor gives the address. This guy will select the particular component. Maybe coming tomorrow, we have a digital electronics session. If you attend the digital electronics session, you will understand the whole thing very thoroughly. You will get a much more clarity. Okay, that's the way it works. Yeah, that's you are writing this. This is what embedded firmware engineer. You are writing the software into the ROM by controlling the ports. That's it. You will get the input and you will give the output based on the requirement. If I say that if the input is 5 volt, then you control the bulb, and after 10 minutes off the bulb. That is what you do, embedded firmware engineer. That's it. This is what you do. Exactly, you write a software for the prompt. We are exactly going to do that next 2 weeks only. That we are, as an embedded system embedded programming, we are going to do that. So what these people did it, there's one more small confusion. There's one small confusion is there. I'm not going to write anymore. The computer is there. I'm not going to write that. Don't worry about that. There's a microprocessor, a ROM, and RAM is there. I will not write anymore here inside because that's repeatedly wasting the time. Now I have let us assume that I have a port. And I told you that I write a program, CHA char X. This is just I'm giving a pointer. And I say X is equal to 30. That is the address of this port, because there's a block here. The output block, which we'll discuss, is nothing but this block is nothing but a 8-bit D flip-flop. That we will discuss in coming classes, digital classes. You will understand more thorough. Here right now, understand about it's a block. Now my computing engine, this guy address is 30. It will do that. But what this manufacturer did is they did it with small extra thing. These pins can act as an input or output, both. So please that understand one thing. This can be an input or output. But how do you know whether to use input or output? That is your wish. For that, they are given a one more address inside. They are given a one more address. Who controls this? This is called direction register. For example, this is 30. They will tell you this is 29. Example. They will tell you that this guy is also, this direction register is also having 8 bits. See, everything is address. Please understand, everything is address. Whenever you want to do anything on the embedded world, you should know what is address. That's it. You use the pointer and write the address, it will be written there. Nothing else. They are not doing anything great. Please understand this. The whole thing is very transparent to you. Don't get confused too much. Now, this 8 bits direction, 0 means input, 1 means output. 0 means input, 1 means output. Understand now? That means that I want to use all the 8 pins as output. Output means 1. I will write here x is equal to 29. Star x is equal to 0x ff. You understand? 0x ff means all ones. This is not, this will not come out. This is I'm writing here. He will make this pin all output pins. Let us say I want to make all the pins as an input. Then I will write 0, 0. Let's say I want half of the pin as output. This top half as output, that is LSB. Then I'll write F. So you can decide which pin to be output out of this 8 pins. You can decide which, let's say I want this as output pin, output, 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 input, input. That pin all are 1. 1, 1, 1, 1, 1, 1, 0, 0. I write here F, C. That means that, so please understand one important thing. Understand one important thing. Every port has 3 address. Every port has 3 address. One is direction control. One is output. One is input. Right now, we are not worrying about input, so we'll discuss about this later. Okay, direct. So in direction, so for example, if I had in a microcontroller, I have about 4 ports. I had 4 ports. That means I have 32 pins. I have 32 pins. I can make any port. This is port 0. Address is 30. Port 1. Port 1. Address is 40. Port 2. Address is 50. Port 3. Address is 60. But this is output port. These are all output port. These are all output port. Out. And they have a one more, every port is having a one more port called direction port. This direction will be another number. Let's say, for example, 29, 39, 49. I'll give an example. I'll show you a data sheet. It will be different. Now, if I write down 49, first I have to write it in 29 to configure that whether the pin is output or input. I say CHAR star X. CHAR star X. X is equal to 0x29. Sorry, 29. I don't put 29. Then star X is equal to, write any value. So 0x50. 50 means 0101 0000. All these pins which are all making 0, these are all input pin. But these 2 pins, this and this, these 2 pins are going to be, output pin. All the other pins are going to be input pins. Understand? You understand that? So for every port, there is a register. For right now, I'm not discussing about. There is one more register called in. That is for 31. You will be trying to read from that. Right now, I'm not worrying about that. I'll explain to you next session when we are discussing about input. Let us learn only one thing now. Let us learn only one thing now. So the out is having required two registers. One is called direction register. Other one is called out register. Whenever you want to output, you should write it output here. But this you will do only once. That's why we call this as a initialization. During init, when you start the program, you will do that thing. Normally you do it now. When you write a program, initially you say that int I is equal to 0. You initialize. Like that, we initialize this only once. Afterwards, we'll be using only this pin. We are going to do a lot of exercise here. When you do a lot of exercise, you will try to understand how to output things. You will know that. So, if I write a program now, let's say, I have to write like this. I have to write two things, character star x. X is equal to 29. Star x is equal to 0x ff. That means that I'm making all the pin as output now. Because we are going to discuss about output. When we discuss tomorrow, we'll see the input. Next session. Now we discuss about all outputs. They're done. This is done. Now you say x is equal to 30. Star x is equal to 55. 55 means 0, 0, 1, 1, 0, 0. Sorry, 0, 1, 1, 1. So this become 1. So learn this method. This is used in every system. No, ROM. These programs are stored in ROM, not RAM. I told you repeatedly, programs are not stored in RAM. RAM is a volatile, that's gone. The moment you switch off the computer, it will go. All the programs, once you compile it, that is stored in the ROM. Not in RAM, please. I took a session already. In the microcontroller session, I discussed about how do we store it in the ROM. You can just go and watch the recorded video also. But the variables are stored in the RAM. But of course, RAM is having address. For example, this guy is having some address 60. RAM will not have the same address. Oh, that's what I've explained in the session. This is not the session for that. You watch the session or go back and watch the microcontroller on the last topic. I said it's how to flash. Already the class is done. Or next session when we're taking, you can take it. We are writing into the ROM. That's possible. So understand one important thing. Understand there's a computer inside. That's why your microprocessor ROM RAM. I don't write this. I don't show this anymore. That is that built in. Your program is done by that guy. Now understand one thing. You as a programmer, you can control only 5 volt or 0 volt. That's it. You cannot do more than that. But now I can do anything outside. Let us assume a very small application. Let us say this is a 5 volt microcontroller. Assuming that. You have a lot of things nowadays. 3.3 volts, everything. I have a LED. I connected here. Now this is cathode, this is anode. So LED is forward bias, but LED is 5 volt you are applying. But the LED manufacturer said you should give only 2 volt and 10 milliampere. Understand? That means that if you give more than 2 volts and more than 10 milliampere, then the LED will blow up. The LED will not, it will get spoiled. That is the manufacturer has given you. No, that is what generally in digital, we use 5 volt, 0 volt. Generally, that's it. But later I'll explain to you that why do you do that thing. Generally, we are using in digital to start with, because digital started with 0 volt and 5 volt. 0 volt means 0, 5 volt means 1. That's the way digital. Somebody has asked me a question, why are we using only 5 volt and 0 volt? No, need not be. This is only started, it was there in the field for quite a long time. But nowadays 3.3 volt, 2.5 volt, 1.8 volt, 0.625 volts are considering. So don't think that it's only 5 volt. Right now, to give an example, I'm doing that. So please understand here, this LED, if you give more than 5 volt, that LED will burn. You are not supposed to, like in your house, you have a 230 volt bulb. If you give more than 230 volt, the bulb will blow up like that. You are not supposed to give more than 2 volt. But pin is giving 5 volt. So we put a resistor. Where we drop 3 volts, it becomes 2 volts. Understand? So this is 3 volt, this is 2 volt. Now, how do I find the value of the resistor? I told you the LED will glow if you apply 2 volt and 10 milliampere. I given a 2 spec. Understand? 2 volts and 10 milliampere. Since the resistor and the LED are connected in series, you have to across the resistor 3 volts. So 3 volts divided by 10 milliampere is equal to 3000 millivolts divided by 10 milliampere is equal to 300 ohm. But normally in market you get 330 ohm, not 300 ohm is not available. So you put 330 ohm. That's why everywhere you see that there is a LED. Why we put resistor is to limiting current. That's a purpose of the resistor. So do you understand this? That is the thing. I'll summarize the whole thing. In any microcontroller, I can have n number of ports. There can be only one port, or there can be 20 ports. Don't ask me that how much it is. That depends on the requirement. You want to control more devices, more bulb, then you buy a more one. That's right. And we are using the 8-bit microprocessor. So all these ports are 8 bits. And each port is having an address. 30, 40, 50, 60 like that. This address is output address. Also, each port is having a direction, control, register. Understand? Each port is having a direction control register. So there'll be 2 addresses. One is 30. This direction could be 29. Whatever it is. That depends on the manual. Depends on the manufacturer. Now, the trick here is, when I have a 29, I write it to 29. This is 8-bit once again. Here, 0 means input. 1 means output. That's it. If you write all the bits 1, then all the pins are outputs. Right now we are discussing about output. We make everything as output. Let us discuss about input later. Then what do here is, if I give you the microcontroller chip, if I give an IC to you, you cannot use it correctly. You cannot use them. You have to do a lot of soldering, everything. For that reason, what people did was they made a printed circuit board, PCB, and they put the microcontroller and they give so many connectors here. They make the connections and give it to you. They make the connection and give it to you. These are called boards. Understand, this is microcontroller, which is inside you have a microprocessor. This is called board, microcontroller board. What is the use of microcontroller board? You get connectors. You can directly connect them and directly control them, anything. That's the advantage. But unfortunately, people made this as a proprietary. People made this as a proprietary. They have not released to public the circuit. You can buy the board from anybody and use it. Of course, there are few college students in about 10 years back. They have started and they had come out with a board. That is why it's famous, Arduino. Arduino is nothing but a board. Don't get confused. And it uses a microcontroller from a company called Atmel. That's all. That guy is also, this microcontroller is also having a ports and address, everything. Nothing to worry. But there was a small hitch while starting with only one small problem with us. The problem is they are given a lot of functions. As I told you, output, input, everything. They are given a function called pin mode, digital write, digital read, like that. If you use this function, you will know that what is happening. That's why generally people say that don't use the Arduino boards, but you can use the Arduino boards, nothing wrong. It's another microcontroller board. There is no difference between another microcontroller board and Arduino board. Why I'm telling you Arduino board is one advantage now, I'll tell you. The trick was, since it's become very famous in the market, you know that whichever product become famous, for that people start supporting. You know that, okay? When Android phone came, everybody started manufacturing Android phone. When IBM PC came, everybody started manufacturing IBM PC. What happened was, this board, Arduino, initially, they did a small mistakes. Not a mistake, it's not out of 8 pins. They use 2 pins for that purpose. They given you only 6 pins. Every port they given you only 6 pins. You will never get a Arduino board with 8 pins. Yeah, super. You can use anything. If you use any board, I'm working on any board. If you want, if you do even STM 32F407 for 401, 302, 103, all are good. You can use it. But the only problem is, there is the curve, reading the data sheet. Because they have STM32, have lots of options. Lots of options. So, if you wish, there may be a 1 day delay will be there, but there's no difference. There is no difference between your this board, what do you call your Arduino board, and ARM board. There's no difference. Whatever you can do in ARM board, you can do it on the Arduino board also. Please understand that. Why I initially will choose Arduino board was, you do not have to spend single penny. Things are available in simulation. And there is no difference between simulation and real actual hardware, real hardware. And one advantage of simulation is you write a program. I'll give you the problem. Like I'm giving a C problem, I'll give you a problem. You solve the problem. You share the link to me. I will check and tell you. Once you have done here perfectly all right, then you can invest money on the board. That time you will decide whether to see, think of a thing very clear. Whether it is you take a car, okay, there is a car with Santro, okay, or Alto, or Corolla, or Benz, or BMW. Am I right? You have so many cars. When you go and start learning driving, you'll never start driving on BMW. Provided if you have a huge money, you can do that. But normally, if you go to the training institute, car driving institute, they will teach you Alto. Because this is a very simple, nothing is there. You need to learn driving. But that driving and this driving are the same. If you learned Alto for over 1 year, then you can be able to ride BMW so easily. There's nothing difference. All are having same thing. That is the same thing true here. So no, what I'm trying to say is that I'm not trying to say don't start with ARM. Please understand. But because of starting with ARM, you should not lose the interest. You understand that point. Because of starting with ARM, you should not lose the interest. That is what my problem. Okay. Is it clear? This what ARM, even you can start with RISC-V, latest one. This is going to be famous tomorrow. Use any processor, all are same. Please, once again, I'm telling you that you are trying to give an importance to the output and input. But I am giving importance to the processing. That is nothing but a C programming. So you can use any simulation software if you know it. But I one of the students only introduced me the few batches back. I did not even know that. Before that, I was trying to do only the hardware. So there is a site called WalkV. I'll show you now. I'll share it now. Okay. I'll share it now. Okay. So there is a simulator. This site, I'll send the code to you also. You can use any board. This is what exactly the modern, see, this is the Arduino board. I mean, this is what you have seen everywhere. Okay. So this Arduino board has see here. Let me start writing here also. So you'll be able to understand. See here. There are two things are there hidden here. One is called void setup. Other one is void loop. The setup is done for one initialization. That is, I told you, whether, let's say, you have so many pins are here available. So many pins are available. Okay. These pins are going to be input or output, which you can able to do that. And here also input or output, you will do that. And very unfortunately, if you see here, this is one port, 8 pins, but you cannot use these two. They use it for different application, downloading the code, TXRX. If you see the another one, you get only 6 pins. Here also they have only 6 pins. So that they did it. There is no port available with the 8 pins here. All we have 6. But later when we are going to do a lot of things, I told you that we always used with 8-bit. So for that reason, both are same. But what I prefer is generally I prefer but when you buy it, it's expensive. When you do simulation, it's free. Understand? This is called Arduino Mega. Here you see that so many ports are there. 1, 2, and here also everything. Okay. I'll share a document. I'll share the document today, and you will be able to understand that. slowly, you will gain it up. There's nothing big. Please understand once again. What I'm going to show now here is, see here, I add a component here, LED. See, this is the advantage here. I can add a LED here. And I connect the LED, but what is the port? You don't know. No? That's the problem. Now I'll share a small document now. I'll share one by one slowly. It's all sometimes tricky one. They did it for hobbyists, but we are going to use it so nicely. This one. Don't worry about the hobbyist or anything. They wanted to make life easier, but I don't want it life easier. I want you to adapt a method which should work for everywhere. See here. I think I hope you are watching. You could see my screen. Well, let me make it big. See here. This is called port F. This pins. This image I can share it to you. No problem. This image I can share it to you. These are all I think available in my Google Drive. I'll share it in the Google Drive, all these documents. Okay, so this is another port. And this is port K. See how many ports they have. Port A and port C, port G, port L, and port D, then port E, and port B. They have so many things. Understand? Of course, they made the pin slightly different way, but this port is very easy to start with. Understand this port. Port F to port F is a very easy. I'll start with normally port F and K. Then you can start other one. Even here also is nice. You have port A, 0 to everything. It's available. PA1, PA2, PA3, PA0. They're all available. So understand this. So don't worry about how many ports this guy is having. They have so many ports. And what chip they have used here is a Atmega 2560. Let me show the data sheet. Let me open the data sheet. See, I'm not trying to confuse you, but I'm telling you, I'm giving you the link. I will link it afterwards. Once you have seen this, then I will link all these things one by one. We take only one port now. I don't want to take any other port. We take only one port. Let me see, where is the 2560? I've taken 2560 now. Data sheet. I have shared all the data sheets in the document. It's available in public. These are all used in, you can. Now you see IO port. Session number 13 is IO ports. In the IO ports, I directly go to the this one. Register this one. Here you see that port A, what is the address? 22. Port B, 21, like that. If you see, we are using here, for example, in our port, we are using port F. Forget about other ports now. We are using port F. Okay, I'm using port F. A0 is 0, A7 is 7. Okay, understand that. So this, I'm using port F. What is the address? Port F. Data register is, that is output. Register is 31. Direction register is 30. Please understand. Forget about input. We'll discuss input next session. We're going to discuss about data register and direction register. This is output register, 31. 30 is direction register. So let me go to the program now. There we write it. Sorry. I did a mistake. I remove the share. Let's go here. Let me write here. I do here. See here. Char star X. If you want to zoom it, I can zoom it. Okay, sorry. Okay, I hope you are watching now. You could see that character star X, same program. I put now X is equal to 0x30 because that is called in our data sheet. In the data sheet, I have seen that as a direction register 30. Okay, what is that inside the bracket? Let's not worry about this. They given us some extra facility. Oh, sorry. Port F. This is the right method. See what I'm teaching you. Maybe you may be slightly confused, but this is the right method of learning. You have to always refer the data sheet. Okay, you have to always now let us. If you get a data sheet, you will see here. For example, if you see overview. Okay, let me see here. You see the port here. See port A, port C, port G. They have all. They tell you that what are the ports it has. Port D, port H, port L, port B. So this is the CPU they have. They have internally EPROM and the RAM. They have a SRAM and flash and EEPROM. They have it. But you have so many ports are here. So this is the way they write the block diagram. Now I have seen the address now. See, even though this data sheet is having 435 page, initially don't try to read all the 435. See the block diagram. This is called overview. And also the pin configuration if you want. Okay, or go to the top of the page. What are the features? What this guy supports? Okay, this is if you could able to understand the feature, then it's great. That is what we are going to discuss in this session slowly. How to understand this. So learn to understand data sheet. That is very important. Don't read the book. Don't read by everything. Go by data sheet. Try to go by data sheet. Now we have IO port. In the IO port, we have seen the register description. There we have seen we are using the port F. Don't get confused, right? Only one port. Now direction register is 30 and data register is 31. That remember only that. Then come here. I have put here X is equal to 30. Then I put star X is equal to 0x FF. FF means I'm making all the pin out. You see here, this is called setup code. And this is called main code. The main code I'm writing now. Char, once again, star out. Let me make a meaningful name. So giving X, I put DAR. Then I put DAR is equal to and star DAR is equal to 0xFF. T mean direction. Out. Now I say star out is equal to 0x what? 31. That is what given by the data sheet. I'm going by data sheet. 31 is given for port F data register and this is 30. I go by data sheet. I'm not referring anything else. I don't go by search of internet or anything. Then I put star, sorry, out is equal to. I put star out is equal to 0x01. But how do I see this one? Now I have connected the LED. Understand? Now LED is having anode and cathode. So anode I connected to the pin. Anode I connected to the pin. Now cathode, I connect to the ground. Before that, I had to add a resistor. I add a resistor here. I add a resistor. Later, I'll tell you how to change the value of the resistor. Right now, don't worry. I'll tell you how to see that. See, I did one small thing. I connected the pins here, A0, and this is, I told you the data sheet, the diagram. This is port F. This is port F. And I used the port F. I have connected a LED's anode, and cathode I connected a resistor, then connected. If you draw a few diagrams, you will understand. Now let me execute here. Let me run the code. There is something wrong here. See here. I have forgot to put a semicolon. Sorry, I forgot to put a semicolon. I execute it. What happened? This guy is not output anything. Okay, let me check here. What is that? If my this one is correct, address is correct, should work. Now the LED is on. Understand? When I did not use this volatile previously, am I right? I did not use the volatile previously. When I did not use the volatile, I have not explained to you so far volatile. I'll do that now. Maybe after a small break, I'll explain to you the volatile. Now I execute it. See, LED is not on. Everything is right. I given a right connection. I give everything. Your program is right. But I did not use the one important thing called volatile. Am I right? I stop it. I execute now. See that? Now it is on. You understand? Yeah, I told you I'll explain to you. So don't be. I'll do that, man. Don't be so hurry. So before that, when I introduce some terminology, I know that I'll explain to you now. That I told you. I'll explain to you after the break what is volatile. This is a very important to know. Every interview, this is the one smallest mistake you will do it in the embedded world. If you don't know the use of volatile, that's why I've given you now. I made the connection right. I did the connection right. I did not use my program is right. I wrote a correct program. CAD, star read, everything is right. Am I right? But it did not work. It did not work. See, everything is right. You know one thing, if it does not work, you will start checking your program. But I didn't do that. I just added a volatile. Yesterday, I shared a document in the group. I hope you would have seen the group. In the group, I have given a PDF write-up about volatile. Okay, I'll do it. I'll explain to you today after a break. So we'll take a break for about 5 minutes. Then I'll come back. We'll discuss this. Even though if it takes more time, also it doesn't matter. We'll do it 7 segment next session. But this has to be understood by you. You need to practice this. Okay, volatile is a nice keyword to understand. Yeah. I'll explain that now. I'll explain what is volatile. Volatile is a very tricky one. Okay, that you have to understand about the compiler for that. But it is not required by the other people, computer people. When you're writing a program in computer, you'll never use volatile. You will never do that. But when you do it on embedded, see the very first program to on a LED, you should know volatile. Understand now? This was not the problem. Is if you use the library of Arduino, pin mode or pin right, everything, you will never know about volatile. when you go to any interview, the first question they ask you is about volatile. What is volatile? This every embedded engineer should know that. So let's have a small break and then we continue the session. Okay.